Okay, guys, welcome back. Today we're going to wrap up radicals by learning how to solve radical equations. We're going to use a lot of the skills that we've learned in the past, including solving multi-step equations and just radical skills in general to solve these, and it's very, very simple. Now, first of all, a radical equation, guys, is an equation that has a variable inside of a radical. So if I have a square root of x here plus 7 equals 9, I have a variable inside of a radical. That is going to be a radical equation, okay? If the radical has an index of 2, which remember, an index of 2 is invisible. You're never going to see the index of 2. Okay, guys, so you're never going to see the index of 2, right? So what happens? When you have an index of 2, it's invisible. It's called a, what is that called, guys? What is that radical called with an index of 2? It's called a square root. So when I just have a radical with no index, it's invisible. Remember, that's a 2. And that's a square root radical equation. Now, let's assume in this particular chapter that all the radicals, okay, are real numbers. Now let's take a second to investigate that. A real number is a number that exists. It's real. What is an example of a non-real number? Well, something like this. Okay? That would be an imaginary number. That's called imaginary. Okay? And it's imaginary because there are no two values that exist in this world that when multiplied together are going to give you -4. Because 2 times 2 is 4. -2 times -2 is 4. Now you can say, wait a second, what about -2 and 2? Are -2 and 2 the same number? No. So if I ever have a negative inside of that square root, it's no solution. Okay, so does that make sense, guys? Okay, we're dealing with radical equations. We're dealing with real numbers. Okay, we're never going to have a negative inside of that radical. If you do happen to come across a negative value inside of a radical, you can immediately stop and say no real solutions. Okay, so before we start learning how to solve radical equations, let's just have a little preview or a visit again, a revisit to solving multi-step equations. When we're solving multi-step equations, please remember that the goal is to isolate the variable. Get the variable all by itself. And remember that you want to solve for x over 1. You don't want to solve for -x or 5x or x over 7 or 2x or 13x. You want to solve for x in the numerator by itself. Hence why I put x over 1. I want to solve for x in the numerator. Okay? Now, the procedure for solving equations, I hope you guys remember. The first one is complete all distributive properties first. If you have a distributive property, go ahead and distribute. Release all those prisoners from jail. Number 2, combine the like terms on both sides of the equation. Step 3, move all the variables to one side of the equation. Number 4, undo addition and or subtraction. And the last one that we know up to now is undo multiplication and or division. But we're dealing with now square roots and powers of 2. So we have one more to add. You undo a square root with a power of 2. You undo a square root with a power of 2. Let's look at this example to show you what I mean. If I have a square root of x, and I want to get rid of that square root, I want to isolate that x, I want to get that x all by itself, there's only one way for me to cancel a square root, and that is by squaring the square root. When you square a square root, they cancel out, and you're left with just the radicand. Yes, sir. Now, Using that logic, if I had a cubed root of x, what would I have to do to get rid of that cubed root? You cube it. You raise it to the third power. And the cube root will cancel out with the power of 3, and you'll be left with x as well. We're not going to be dealing with that, but I'm taking you a little bit ahead. You're going to deal with different kinds of radicals in Algebra 2. So you already know the concept. So if I want to get rid of a square root, I raise it to a power of 2. Done. Vice versa. In order to undo an exponent of 2 or a power of 2, you use a square root, like in this example. If I have x squared and I want to get x all by itself, I got to get rid of that power of 2. And the only way I can get rid of that power of 2 is by taking the square root of it. Because the square root cancels out the power of 2, and I'm left with x. That is the reason that the following occurs. Remember that I've been repeating to you guys, whenever you multiply the same radical, come on, what's going on there? Whenever you multiply the same radical, it equals the radicand. Let me show you why. Square root of x and square root of x, they have the same index, so I can multiply them. So I'm going to have the square root of x squared. Doesn't x, the square root, cancel a power of 2? And I'm left with x. So that's why whenever you multiply the same exact radical times itself, okay, you're going to have the radicand left over as the answer. Does that make sense, guys? So you cancel out a power of 2 with the square root, and you cancel out a square root with the power of 2. You guys with me? And remember, the one last thing, very important. Please remember, whatever you do to one side of the equation must be done to the other side. That's not a new concept, but I want to make sure that I drive it home, because it's really, really important. Whatever you do to one side of the equation must be done to the other side of the equation. Okay, sir? Whatever is done to one side of the equation is done to the other side of the equation. So if I multiply 5 on one side, I got to multiply 5 to the other side. If I take a square root of one side, then I got to take the square root of the other side. If I square one side, then I have to square the other side. Whatever you do to one side of the equation must be done to the other side of the equation. There are no exceptions. Okay? Thank you, sir. All right. Now, when solving radical equations, you have one extra step to do as well. It is very important to check your answers for what we call extraneous solutions. And extraneous solutions are solutions which do not work when plugged back into the original equation. When you solve radical equations, sometimes you'll get one answer, sometimes you'll get two answers. The answers that you get are called apparent solutions. Apparent solutions. Those are the answers that you're going to get. But these apparent solutions must be tested. If they work in the original equation, then they are real solutions. If they do not work in the equation, then they are extraneous solutions. So no matter what, regardless of how easy it is, you always have to plug your answers, your apparent solutions, back into the original equation. For example, let's start solving. Solve each equation and check your answers for extraneous solutions. Okay, using our skills of equations, what are we going to do here to get that x alone? Okay, what are we going to do here to get that equation alone? That x alone. Okay, what are we going to do? Thank you. We're going to follow the order of operations for solving equations. Did I have any distributive property? No. Did I have any exponents? No. Is anything being multiplied to the x? Is anything being added or subtracted to the x? We undo addition and subtraction first. Square root of x equals -6. Now that the square root of x is all by itself, how do I get x? What do I do to cancel out that square root? You square both sides. The square root gets canceled by the power of 2, and x equals 36, because -6 times -6 is 36. That is a apparent solution. That is an apparent solution. Now we got to test it. So let's plug it in. Square root of 36 plus 8 is supposed to equal 2. Square root of 36 is 6. Does 6 plus 8 equal 2? No way. So this you have to label extraneous solution. So that is my answer. It's an extraneous solution. So that means it doesn't work. Sir? A -6. What? When I square 30, what? What? No, no. Does it have a plus or minus in front of it? So it's not a plus or minus root. No, sir. No, no, no. No, no, no. You have to plus or minus when you square root something. Yes, sir. Is it okay on the quiz to abbreviate it? No. Just write the word extraneous, please. Thank you. B. What do I do here? First, what's the first step in a two-step equation? Because basically I got a two-step equation here. You undo addition and subtraction first, so you add 8 to both sides. I've got 3 times the square root of x equals 15. How do I solve for my x here? You would divide 3 to both sides. Absolutely. The last step, according to the rules we just went over, was to get rid of that power of 2 or a square root. How do I get rid of a square root? By squaring it. So I'm going to square both sides. The square root gets canceled by the power of 2. X equals 25. That's an apparent solution. Let's see if it works. 3 times the square root of 25 minus 8 has to equal 7. Square root of 25 is 5. 3 times 5 is 15. 15 minus 8 is 7. Bingo. That is a solution. A real solution. Sir. Just leave it like that. That's it. If it's extraneous, you must label extraneous. If not, and you just leave x equals 25, for example, here, the reader knows that works. Sir. I'm sorry, come again? I did divide by 3 first. No, but after addition. Guys, I went over the rules for equations on purpose. It says very clearly here, you undo addition and subtraction before you undo multiplication and division. We just went over this, right? The steps are, do all distributive property, undo any exponents if you have them, combine like terms, move the terms to one side, undo addition and subtraction, undo multiplication and division. If you guys don't know how to solve a regular equation, this is going to be very, very hard for you guys. So you must follow directions, please. And thank you. Next, C. What do I do here first? You're going to undo addition and subtraction, so you're going to add 5 to both sides. Now I have square root of 4x plus 1 equals 5. How do I release that x from the square root? You don't multiply it by 2. No, that's wrong. You square both sides. Square root and a power of 2 cancel, so you have 4x plus 1 equals 25. Now this is a really easy two-step equation. Subtract 1 to both sides. Thank you, sir. That's 24. And then you divide by 4 to both sides. Thank you, sir. And x equals 6. That's an apparent solution. Let's see if it works. Square root of 4 times 6. Okay, so that's 24 plus 1 minus 5 has got to equal 0. 24 plus 1 is, square root of 25 is, 5 minus 5 is, so it works. That's my solution. That makes sense, gentlemen. Okay, D. What do I do first? I got to solve this bad boy. Yes, sir. Very good, son. You're going to undo addition, subtraction, so you're going to subtract 3 to both sides. Very good. Leave me with that square root all alone. That's what I need. Because once that square root is all alone, oh, maybe I should learn how to add. Once I have that, square root alone, I can get rid of the square root by squaring both sides. Excellent, sir. When I square a square root, I cancel the square root with the square, and I got 2x minus 3 equals 25. How do I solve for x here? Yes, sir. You add 3 to both sides 100%, sir. And then you have 2x equals 28. You divide by 2, exactly correct. And x will equal 14. Now we got to test this, though, my friends. So 3 plus square root of 2 times 14 is 28 minus 3. That has to equal 8. What's 28 minus 3? What's the square root of 25? What's 3 plus 5? It works. That's my solution. You guys with me so far? All right. Now, this next one's we're going to add a little bit of an extra twist to it. You guys remember last chapter we learned how to factor? Remember I told you that was not leaving. We were just having a little break from it. Well, we're coming back to it right now today. Okay, I have an x equals square root of 3x minus 10. Nothing is being added to the square root or to the x. Nothing is being multiplied to it. So how can I get right to it? How can I get that x out of that square root radical? You square both sides. Very good. So I'm going to have x squared equals, the square root cancels with the power of 2, 3x minus 10. Now, if you guys remember, we learned how to factor binomials and trinomials and 4-term polynomials. So this has 3 terms, so I got to create a trinomial. How would I create a trinomial here? By moving things. How would I do that? How do I move the 3x and the negative 10 to the left? Very good. You're going to subtract 3x and you're going to add 10 to both sides. So that's going to give me x squared minus 3x plus 10 equals 0. And I made a little bit of a boo-boo here. I'm so sorry. Follow me. Make that a plus in the radical. Sorry. Make that a plus. My bad. Completely no excuse. I just realized that I screwed up and this is not going to work like that. I'm so sorry. Sorry about that. So So instead I got to subtract 10 to both sides, so that's a negative. I'm really sorry about that. No excuses. That's my fault. Okay? So, you guys got that trinomial? Yes, sir. You guys have the trinomial? Okay. How do we factor this trinomial? You go x and x. Remember, what times what equals negative 10, but when added together equals negative 3. Negative 5 and positive 2. Very good. Is everyone with me so far? Make sure you're with me because I'm going to have to teach you a new theorem today, right now. So I want to make sure everyone is with me so everyone can pay attention. Sir.
Wait, how did you get that?
It's called factoring. What times what equals negative 10, but when added together equals negative 3. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Remember, we took a test on this already and several quizzes, and I promised you guys that we'd be back on this, and I'm going to give you another promise. Next chapter, it's filled with factoring. Crazy amount of factoring. So we really need to make sure we've got this. Thank you for your honesty, sir. Now, everyone is with me here? Okay, guys. I've got to introduce to you something that's called the zero product property. And the zero product property allows us to solve this equation here. The zero product property states that if A times B equals 0, then A equals 0 and B equals 0. So what is that saying? That's saying that when I have two polynomials or 3 or 4 or 5 or 20, when I have the product of several polynomials equaling 0, every single one of those factors must be set equal to 0. So since I have that x minus 5 times x plus 2 equals 0, these are the factors of this polynomial. So that means that I have to set x minus 5 equal to 0 and x plus 2 equal to 0. Add 5 to both sides. X equals 5. Subtract 2 to both sides. X equals negative 2. So these are my two apparent, that's an ugly 5. These are my apparent solutions. Does everyone get this so far? Because now I got to plug it in to see if they work. You promise? Okay. Now let's plug in, buddy. We got x equals 5 or negative 2. So let's check when x equals 5. When x equals 5, let's see if it works. Does 5 equal square root of 15 plus 10? Okay, for those of you that are saying no, think about it before you speak. This is 25. Square root of 25 is 5. Yes, 5 does equal 5. Yes, it does work. You guys are going to have to actually work things out. You do not have the ability to just look at something and know it. Very few people do. So instead of suffering, guys, follow the rules all the way, and you'll see that you're going to get a lot better results. I promise. So 5 works for sure. That is a solution. Now let's see if negative 2 works. Does negative 2 equal the square root of, what's negative 2 times 3? Negative 6 plus 10. So that's negative 2 equals the square root of 4. Does negative 2 equal 2? No. Now for those of you who are saying, wait a second, Morrow, wait. That's plus or minus, dude. No, it's not. I don't have a plus or minus here. So it's just the positive root. Does negative 2 equal 2? No. So my answer would be x equals 5 and x equals negative 2 is extraneous. And yes, you have to write it out. Extraneous solution. No, it's called an extraneous solution. If it was called an exception, then I would have taught you that it was called an exception. But it's called an extraneous solution, sir. But thank you for asking, sir. Does that make sense, boys? Okay, now, let's do another one. Let's do another one. Let's go ahead and erase the zero product property, and let's knock this out. Okay, how do I get that x out of the square root? Sir, you square both sides. Very good, sir. What's negative x squared? What's negative x squared, guys? Negative x times negative x is x squared. Did you guys forget all the skills that we've learned? When you multiply a base times itself, don't you keep the base and add the exponents? And a negative times a negative is a positive, correct, guys? Okay, so negative x squared is x squared. The square root gets canceled by the power of 2, so that's 2x plus 48. I have to make a trinomial, so I subtract 2x and I subtract 48 to both sides. Now I have x squared minus 2x minus 48 equals 0. It's not negative x squared because a negative times a negative is a positive. Okay? Thank you, guys. Now, let's go ahead and factor this. X. What times what equals negative 48, but when added together equals negative 2. Sir, negative 8 and positive 6. Very good. Awesome. Now, we have to do the zero product property. So we must set x minus 8 equal to 0 and x plus 6 equal to 0. So x will equal 8 and negative 6. Is everyone with me? Now let's see if it works. Let's see if it works, guys. Let's see which one of these works. Okay, let's try with when x is 8. Does negative 8 equal 16 plus 48? Negative 8 equals square root of 64. Does negative 8 equal 8? No. So 8 is extraneous. And then you plug in for when x is negative 6. Negative times negative 6 is 6 equals negative 6 times 2 is negative 12 plus 48. 6 equals square root of 36. 6 does equal 6. Bingo. So that is my answer. So I would say x equals negative 6 and x equals 8 is extraneous. Does that make sense, my brothers? Yes? No? Maybe kind of, sort of? Awesome. Thank you. Okay. Let's continue. Let's look at how we can use this in a word problem. The time it takes in seconds for a pendulum of a clock to complete one full swing is represented by the equation t, which is seconds, and time for seconds, equals 2 times the square root of L divided by 3.3, where L is the length of the pendulum in feet. If a pendulum of a clock completes a full swing in 6 seconds, what is the length L of the pendulum? This is Mickey Mouse time, guys. Check this out, how easy this is. You just plug it in. What did they give you? What variable did they give you? There's 6 seconds. What is that? The t. Very good. So doesn't 6 equal 2 times the square root of L over 3.3? Okay. Is something being multiplied to that L? What is being multiplied? How do I get rid of that 2? Oh yeah, divide by 2. So I got 3 equals the square root of L over 3.3. How on earth do I get that L outside of there, my brothers? That's exactly right. You square both sides. So I get 9 equals the square root gets canceled by the power of 2, L over 3.3. How do I solve for L now? Multiply 3.3 to both sides. Very good, gentlemen. And 3.3 times 9, you got a 7, 2. Oh, that's it. There's only one. And 1 decimal, boom. So I got 29.7 feet equals L. Gotta have labels, my brothers. Gotta have labels. It's not hard at all. Thank you for realizing that. Good job. Very nice and easy. You just plug and chug. Just plug it in and solve it. Okay? All right, may I continue? We got one more page. All right, let's do this. All right, let's put it all together. Let's just practice, okay? Now remember, solve each equation. They're not always going to tell you, Oh, by the way, check for extraneous solutions. That is something that you have to do, and you got to know you got to do it. Okay, my brothers? So let's start. What do we do here? How do I get this x alone? Subtract the 5 to both sides. Fantastic. That's negative 3 equals square root of 2x plus 1. How do I get rid of that square root? Oh, yeah. Square both sides. So 9 equals 2x plus 1. Subtract 1. Good job to both sides. 8 equals 2x. Divide 2 to both sides. X equals. Oh, yeah. Let's see if it works. 2 equals 5 plus square root of 8 plus 1. 2 equals 5 plus, plus 3? No. So that's going to be extraneous. Does that make sense? Okay, guys. Now, we checked it. It's not, so it's extraneous. Next, how do I solve B? Square both sides. We've got a few minutes. I'm going to speed it up. Square root gets canceled by a power of 2. 8x plus 1 equals 25. Subtract 1. 8x equals 24. Divide by 8. X equals 3. Let's see if that works. 8 times 3 is 24. 24 plus 1. Does square root of 25 equal 5? Yes, it does. It works. We're good. 2 more. Let's see if we can knock this out. Okay. This is a good one. Pay attention to this one, guys. This is awesome. How do I get that y out? Yeah. If you add this 2, you're not doing anything, right? Because you can't add this 2 to the inside here. So you got to get rid of the radical here. You're going to square both sides. This is where a lot of skills are going to have to come into play here. Square root cancel the power of 2. I got y plus 10 equals. This is a perfect square. So it's going to be first term squared minus 2 times the first times the second term plus the second term squared. If you didn't remember that from a couple chapters ago, I suggest you learn it. If not, you're going to have to go the long way and go y minus 2 times y minus 2 and do FOIL. But we are already past that method. I have taught difference of squares and perfect squares many times, so please learn it. Subtract y and subtract 10 to both sides. 0 equals y squared minus 5y minus 6. What times what is negative 6, but when added together is negative 5. It's going to be negative 6 and a positive 1. You got to set y minus 6 equal to 0, y plus 1 equal to 0, so y will equal 6 or negative 1. Now I must plug it in and test this. So let's check it out when y is 6. If y is 6, it's going to be square root of 16 equals 6 minus 2. Square root of 16 is 4. 4 does equal 4. 6 works. Let's try negative 1. If y is negative 1, I got the square root of 9. Negative 1 minus 2. Does 3 equal negative 3? No. So y equals 6 and y equals negative 1 is extraneous. That make sense, guys? Yes? All right. We have one more, but you could do that on your own. Okay? It's not that bad. Actually, I'll just finish it up now here while you guys leave. Yes, sir. Sometimes you have to test each one. Let me just go ahead and finish this right quick. You guys can go ahead and get ready. Got to square both sides. I got 7x minus 3 equals 4. Add 3. Add 3. So 7x equals 7. Divide by 7. Guys, chill. Chill. X equals 1. Let's see if it works. 7 minus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. Yes, it works. Thank you very much. Have a great day. God bless you all. Homework is valid.